Okay, so the first question on your warm-up was seawater contains roughly 28.0 grams of NaCl, which is sodium chloride, per liter. What is the molarity of sodium chloride in seawater? So what we have to remember, since the question is asking for molarity, remember that the equation for molarity is equal to the number of moles per liter. So that's going to be moles of solute per liter of solution. Okay? And if we're looking at what we're given in the problem, we're given 28 grams of sodium chloride per liter. So we already have this per liter part. And again, if there's no number there, it's understood that that's per 1 liter. Okay, so now what we have to work with is this 28.0 grams, and I need it in moles. So I'm going to start with my given, 28 grams of sodium chloride. Set up my little ratio thing here. According to the periodic table, the molar mass of sodium chloride is going to be 58.443 grams of sodium chloride, and that's in every 1 mole of sodium chloride. Okay. Of course, grams of sodium chloride cancel, multiply across, divide by the bottom, and we're given 0.479 moles of sodium chloride. Okay, so almost half a mole of sodium chloride. We plug this value into our equation for molarity. 0.479 moles per, or divided by 1 liter, since it was per liter up here. Anything divided by 1 is that same number. So the only thing that changed now is instead of saying moles per liter, which we could still say, we say that the molarity is 0.479 molar. Okay, so the capital M stands for molar, which is the unit for molarity, or we could say moles per liter. The second question is actually comparing which one has a higher concentration. 73.0 grams of HCl, and hopefully you remember that HCl is an acid since we have hydrogen bonded with a halogen. So hydrochloric acid in 450 milliliters, or B is going to be 80 grams of sodium hydroxide in 505 milliliters. Okay, so I do want to point out that this is a multiple choice question, and though I didn't explicitly say so in the Check Your Learning, multiple choice questions are to be done without a calculator. So I'm going to go through this problem without a calculator, which means any masses, any molar masses that I find from the periodic table, I'm going to round. Okay, so again, we have to remember the equation for molarity is the number of moles per liter. And we do this so that we can have the same base comparison for volume to make it fair. The first one part, or question A, choice A, we have 73 grams of hydrochloric acid. That's going to be 36.5 grams of hydrochloric acid per 1 mole. This is 2 moles of hydrochloric acid, okay? If you can't see this without a calculator, 36 times 2 is 72. 0.5 times 2 is 1. 72 plus 1 is 73. Okay, so this is exactly 2 moles of hydrochloric acid. So then we plug this into our equation. Molarity is equal to moles over liters. Our moles was 2. Our liters, okay, so we're given milliliters. So we have to remember that there are 1,000 milliliters in 1 liter. So we move the decimal 3 times to the left, so we get 0.450 liters. And I'm pretty decent at math, but I'm not that good to get an exact number, so I'm not actually going to solve this just yet. I'm going to go ahead and start working with answer choice B, starting off with 80 grams of sodium hydroxide, which is about, rounding the masses, 40 grams of sodium hydroxide per 1 mole. Hopefully this one's a lot easier for you to see. 80 divided by 40 is also 2 moles of sodium hydroxide. We're going to plug this into the same equation, 2 moles of sodium hydroxide per, in this case, 505 milliliters, or 0.505 liters of solution. Okay, now that we're looking at this, we have the same units, moles per liter, moles per liter. And since we have the same number of moles, we can just look at our denominators. If we're dividing by a smaller number, we have less solution here, so that means we're going to have a higher concentration because we have less total solution. Whereas here, we're going to have more water in it, so we're going to have a greater volume of solution, so those particles are going to be spread out just a little bit more. Okay, so think about like the Kool-Aid example. We had a little bit more, oh no, that was different solute, sorry. If we add more water, then we have a less concentration because those solute particles are more spread out. Okay, if you don't believe me, go ahead and check your calculators. 2 divided by 0.450 is approximately 4.44 molar of hydrochloric acid. 2 moles of sodium hydroxide divided by 0.505 liters is 3.96 molar of sodium hydroxide. So the one, when the solute amount is the same, the one with the lesser amount of solution is going to have a higher concentration.